Okay, so let's start our today lecture and class. Our class today will be devoted to open science, and we will work today in open resource. For you, it is a near-port presentation, and if you still haven't joined, and I still that only 9 students joined, please join this presentation and join this tool. Here you can see the code which you can use, and in our chat and Zoom you have a link. Please follow this link and join the presentation, because we'll work together today. And you will have all the slides, all this information, and which is more important, necessary links, because these links are really important for you if you want to become an open science researcher. I'm sure that by the end of our lecture, you will clearly understand that that is critical today for you to become open science researcher. Those links will be really, really useful for you. Okay, so it's the open science is a new trend, and it's been a lot of information about this, and different myths, facts, why, how, maybe not, maybe yes, what is the benefit of this trend, why should we make everything open, and so on and so forth. So even if you look at this picture or an infographic, which I just suggested you on the title page, we still have doubts. I don't know, some maybe fair that maybe we shouldn't do it. Maybe it's not something that worth trying. But when we today together with you, while we are approaching the outcome of our today's lecture, you will see that it is really something worth trying. And in today modern scientific and research ecosystem, it is impossible to be not open. And let's first of all just go down to earth, and I will ask you such simple questions. For example, if you don't know the way from your university to someplace in your city, what do? You open Google Map, or you open some kind of even offline map, it doesn't matter, and you find information. If you want to see the level of air pollution in your city, what do? You do the same. You just find this data open, and you get this information. If you want to see the amount of taxes you paid, or I don't know, people in your country pay, the same. You just find this resource, find this data, and you use it. It doesn't matter for what, for your personal use, or you can use it for your study, for your research. Doesn't matter how. Due to technologies, a lot of information and a lot of data are open today, and they really, literally make our life simpler and easier. So if we can use this open, sometimes data which was prepared by government or by some scientist or economist, it doesn't matter by whom, but they open this data. And why, if we make our life, personal life, easier, why we shouldn't do it with our scientific life? So I think that is pretty obvious that this open science and open data principles and values are really important today. So before we just discuss with you step by step open science principles, practices, and so on, here are some statements for you to vote. So in Nearpod, and that you can use your phone or whatever where you work, your personal computer. You can read this statement. Open science means making all research data publicly available immediately. And you choose, what do you think? Is it myth or is it a fact? True or false? Just let's little bit make a diagnostic assessment, evaluation of what do you know about open science.
Juliana, very nice tool, this Nearpod. I have never heard it. So
yeah,
I will ask the students or the participants to take, the experience. It's really nice. Thank you.
Yeah, it's really to make such things interactive. So please, you just click, and here just for course this is for teacher, and maybe we have here some future teachers. You can see here two options, like you see like a student, and now I want to click and to see like a teacher, and here I see the results. You see, so A, 3 points, and someone, people still voting. B, 3 points, equal. Let's wait. So open science means making all research data publicly available immediately. You've just discovered something, or you've done your research and you just publish it. Okay, the right answer is that this is not true. That is not the fact. It seems that open science is available immediately. However, actually not, because to make your data or metadata, we will discuss this difference today, to make it open, people should verify if your data is credible. You should make your open science and open data responsibly. And there are some criteria according to which you can upload your data and make it open. Today we will discuss this criteria. So if you see open data, it means that was verified, that is credible, and you can trust this data. And it means that it cannot be done immediately. It requires some time and skills I will share with you today. The next point. Open science practices can increase the reproducibility of research. Even if you don't know what reproducibility is, try to guess. We will discuss it later in details, but you can just differentiate that something produce, something to make something. So please, your responses. Is it true or false? Myth or fact? Let's follow your choice. More people just have chosen parent option B. Yeah, that is a fact. Reproducibility means that I can repeat, literally repeat the study that was suggested by someone. Why we should do it, in which way we should do it, what for, we will discuss, and how, we will discuss a little bit later. Okay, for students who have just joined, please join not only our today's Zoom lecture, Zoom meeting, but please join this tool, which will work together today. If you want to join, and I ask you to join, I highly recommend you to join, you just enter this nearpod.com, and then you enter this code, which is here at the top of the screen. So please use it. Okay, let's move on. So the next statement, preprints are a form of open science that allows researchers to share findings before peer review. If you have experience in publishing your papers, you know that peer review is something that is absolutely mandatory. If you want to be published in a well-respected, credible journal, peer review is a must. But what about preprints? And what does it mean? Why should they do something before I publish? Is it legal? Is it illegal practice? What if someone, like, this common myth, what if someone steals my data or my research? So what do you think? Is it true or false? Myth or fact? Okay. Fact. You see most 42, 43. Okay. 43% that this is true. Yes, this is true. I think that it might be frustrating for you and unusual that I have to publish something before publishing and before peer reviewing, before someone asks me to correct some mistakes or maybe something like that. But yeah, this is a common practice and we will discuss it in details later. And the last statement. Open access publishing is always free for researchers. Open access publishing is always free for researchers. True, false. Uh-huh. Uh-huh. 60%, yeah. 60% false. Really. Open science doesn't mean free of charge science. Yeah. So it has some journals, and also this is a topic for our discussion today about open access and free or not free of charge. But actually, there is a practice that some journals are free of charge, but some journals they require charging for articles processing, for publication fee. So it's not always free. So please don't confuse these two concepts. Open access and open science doesn't mean that everything you can get is absolutely free for users or for researchers or for students. Sometimes you really need to pay even if you use some open science repositories. Okay, so let's move on. We've clarified with you some facts and we've debunked some myths. And now it's time to dive deeper into the concept of open science, principles, values, practices, what to do, how to do, and why to do. And, it really helps us to formulate, to organize research ecosystem that is visible, trustful, absolutely transparent, and it helps us avoid a lot of mistakes, misunderstanding, and publishing a lot of some kind of misconceptions that can be harmful for people. And even if you remember, it happened not long time ago, just COVID research and COVID, there's communications when people couldn't see face to face each other. Scientists couldn't communicate and discuss everything in their conferences, but due to technology, like today, online video messaging and the open science, the vaccination was invented and implemented rather quickly. So due to open science, due to this transparency, visibility, and reproducibility. Okay, so here is definition of open science. It is a global movement that aims to make scientific research and outcome freely accessible to everyone. Not free of charge, but just freely accessible. It really increases the accessibility level to everything that you need. And it provides equal access to the science, to data, to metadata, despite your role allocation. It doesn't matter where you're a PhD student, MA student, if you're a professor, everyone can access to data. And that is great idea. And due to this, you shouldn't wait 5 or 6 years while you become a professor and then you can produce and make some discovery. No, you just have this data, you reuse, adapt, reshape, and then we can see your new ideas and new product based on someone's open data. But maybe those people, they didn't have enough time or they didn't have enough resources to produce something meaningful, but you got new idea, used their open data, and voila, we have a vaccination. Yeah, we have a new medicine. So it's really the engine of today's science. And the president of Open Science Coalition, suggested this. It was his report, and I took the quotation from his report where he mentioned that with effect from 2021, all scholarly publication on the results from research funded, and it's important because we are researchers and we often apply for different fundings and projects. So all research funded by public and private grants provided by national, regional, and international research councils and funding bodies must be published in open access journals, open access platforms, and they should be made available through open access repositories. So if you apply to grant or to fund for funding your research without knowing what open science is and how to provide all these things, how to upload and where to upload, what is it, open repository, what it means, open access journals, you just don't get your grant and your money, even if your idea is brilliant, breakthrough, and so on and so forth. You just don't know how to make it open. It means that you don't get money, you don't get funding. So that is why it's important in today's studying and scientific world. Okay, so UNESCO developed, and here in this infographic, you can see key values and key principles of open science. So first of all, let's discuss with you values. You can see there are 4 values of open science. So first one is quality and integrity. You remember, coming back to our first statement, that open data becomes open immediately. So if it was so, the data wouldn't be of high quality. So the key value that the data which you make open should be of a high standard and should be verified by peer reviewers or by your colleagues or by, I don't know, some people, experts who just know what it means. And it will ensure that the quality of your data will be reliable and trustworthy. Collective benefit. Science in general cannot be done by one person. You know that the whole notion and whole concept of science is about collaboration. So equal collective benefit, it's about equal opportunities, as I've told, despite your role and location. Equity and fairness. So this is again about fair and trustful science and data which you upload. And diversity and inclusiveness. All people have equal access to everything they want to find and everything they need to produce something or to carry out some kind of a research. Principles. So first you can see transparency, critique, and reproducibility. So it means that when you shouldn't be afraid that someone might tell you that I think that this might be corrected, or maybe this statement is not that important, or maybe here is possibly mistake, just check and verify. You know, all this critique is just to make your research and make you paper better. We are full of our ideas and sometimes we can skip. We are all humans, it's okay. So people around us, colleagues, peers, they help us. So the first principle is transparency, acceptance of critique, and it will help us to develop this reproducibility. And even when people try to repeat your research, your way, how you achieved the conclusion or outcomes, even on this way, if people find some mistakes, it is okay. So they will point you out and you will just improve your study. Collaboration and participation and inclusion, we've discussed. And it's also about critique and transparency. So all these principles are interrelated. Equality of opportunities, responsibility, respect, and accountability. Responsibility, it means that you have to be responsible for everything you make open. And everything that you use, which has already been open, it is about academic integrity, it is about common creative license, and it's about something that I trust you, I will open my data, and then if you need, you can reuse it, but with proper credentials and with proper references. Flexibility, it's really, you know, in our time is very important to be flexible and adaptable. And in case if your peer or expert finds a mistake due to this openness, you can easily check it, verify, correct, change something, because you remember also in our statements we discussed with you that before you published something that cannot be changed, you do pre-registration and pre-prints. And on that stage, when you are on a pre-registration or pre-print, you can really easily adapt, change, transform something just to improve it. And that is why flexibility is one of the principles of open science. And sustainability. Sustainability is a words of today's life, and it's impossible without this. Even if you apply for funding, you also have to specify what sustainability of your project is. It's something that will live longer, even without funding, even without efforts. But this, your product, your data, your paper, it will continue their personal life, and they will bring benefits to people in long term goal. Okay, so if you think that open science is only about open access and open data, you are mistaken. Look at this open science taxonomy. This is a huge family of strategies, concepts, practices. So everything that was open, it's understandable that it is about open science. But for example, you can find here such things as gold route, green route of open access. Interesting, yeah? So we will discuss with you what it means. Or, for example, webometrics, or ORCID, or, for example, institutional policies, governmental policies, organizational mandates. So all these are parts of open science. So open science has key practices, and here are these key practices, which are then divided into more strategies and more practices. And even this taxonomy is not full for today. There are a lot of more practices that have been added recently, but these are the key practices. It's open science practices. And some of them we will discover with you today. So, benefits. I've mentioned today some of these benefits for researchers, and here you can see this pyramid of benefits, not only for researchers, as we are with you, but for usual people, for countries, for governments, for citizens, even economical benefits. It's really important. And for example, I mentioned today the policy, governmental policy, for example, related to taxes. All countries have this tax-free open data where you can find all necessary information. Or if you want to see some kind of tax declarations, you can also find this. This data can help make our life not only easier and better, but it helps us save money. Because if I want to carry out some kind of research, but I need very expensive, I don't know, laboratory or samples or something like that, I don't have money, I'm just a student, I can use someone's data and then produce my research. In this case, I will save my money, and it's just an example of one person, but it can be done on the level of a country or institution or university. And the economical benefit of open science is also rather clear in this term. Um, or, for example, now you all use AI. Before we used, for example, Google Translate. How could Google Translate train to translate all these things which you wanted without open information? Because they were trained on open documentation, open resources, open texts, doesn't matter what, but it was possible due to all this open data and open resources. So the benefits of open science are endless, and if everywhere in your usual life, in your scientific life, in your educational life, doesn't matter, professional life, you can find lots of these benefits personally for you and your university or company, doesn't matter really. Okay, so we're step by step moving to the research life cycle. And open science penetrate or accompany every step of a scientist. So here you can see the first step, what you do when you enter the science and you decided to publish something or to carry out research. So what you do first, you search and discover data, information, resources. Then you develop your idea, design, study. The third, acquire materials, collect data, then you have to store this data somewhere, analyze data, then interpretation, report, and publishing. So this life cycle is known to you. It's not something new. What is new? You can see here digital online tools, platforms, repositories. All these things are for open science. And every step is accompanied by some open science practice and open science source. For example, if you want to develop your idea and find some data, you can go to Mendeley platform or Zotero platform, or this is a great repository of resources and literature and papers, journals, whatever you need, you can find there for your inspiration, or just we discussed with you, make a literature review and find the gap which you would like to develop. If you don't know how to design your study, please, here is a tool, open tool for you. You can find examples, templates, use it openly, and please, you can develop. And there are more of them. Some of them we will look at them in details. Some of them you will just do it in your self mode. And here is a resource which I found for you, and this is resource provided by University of York. And here I wanted, if you click, if you follow this link, you can open this page in your device, doesn't matter, or here I will open and show you. I want to demonstrate you what exact open science practices accompany every step of research life cycle. So first, you remember it is about developing idea, what you're going to do. So when you develop your idea, you can see here 5 practices or activities of open science which you might use on this stage of your idea development. For example, pre-registration or registered reports or protocols, open study protocols or research protocols. They're similar to pre-registration and reports. Or open notebooks, even where you share your whole project or some maybe parts of your project through, it's like, notebook when you have some ideas, but it is open and everyone can just read it, maybe suggest something, maybe, and you can read someone's open notebook and find their idea if you, for example, stuck with something. So this is on the stage of development. Then stage of material. You acquire some material, data, metadata, and in this case, you need to know what is participatory research if you carry out sociological, for example, study, citizen science, and open data reuse. Participatory research encourages people to share knowledge between the researchers, and it means that if you see interesting open data or open resource, you can easily connect to the author of this data and, for example, suggest your help or suggest your participation in this, and then you will provide a great collaborative project, for example. Citizen science, it's a kind of participatory research, but not something that deals with authorship, creators of study, but people who participate. It means that you can provide a questionnaire for people to find out their opinion about something, or you just involve people into assessment or evaluation of a product or methodology, some kind of this. So you involve citizens into your research. And again, how you can do it? If you just make it open, and people who think it might be interesting for them, they just join your study. And of course, open data reuse. I told you that key points of open science, when people can reproduce your study, they can reuse, adapt, reshape it. So if you allow, of course, because you can use very strict common creative license, where you just forbid people to use it for commercial use or to share it in some improper way. So if you can really control the level of this openness. But anyway, open data can be used to extend findings of previous research and find that gap, for example, which you need just to search. Okay. Next step is process. When you process your data, you just perform data analysis. Here you can find this necessary open science practices as data management and open sources software, which help you to calculate, to design graphs, visuals, and something like that. We'll also discuss it later. And publish. You've done everything and you are ready to publish. And before you publish, you need to know about what open peer review is, what preprints is, what open data sharing is, because some editors and journal, they require from you to upload your data before publishing and even before peer review. Yeah, there is a question in chat. Can you find available data on open science today? Which links? Yeah, I will demonstrate you a little bit later. Links to these practices and resources, where to find, and we will just do it with you practice. Don't worry. Okay. So let's move on. And here you can see this word, fair. You know, fair, it means something like to use for people who really can judge and they can find the link between causes and consequences. So speaking about open science, FAIR is an acronym which stands for findable, accessible, interoperable, and reusable data. And these are the principles of open science. Let's discuss them in details. Yeah. So just I'm checking if I haven't forget the key points. Yeah. Here is the resource which clearly explains you what FAIR principles are. We don't have a lot of time, but I just want you to demonstrate what it means, how it works, and where you can find necessary information. So let's have a look at the first principle of open sign, this is a findable. So every data should be easily findable, data or metadata. Firstly, let's discover with you this difference between data and metadata. When you carry out your research, you collect data. It might be, some mathematical data, maybe some kind of measurement, statistical data. It might be data, not quantity or on quality of something. It doesn't matter how you measure it, but this is the data exactly of your research. But when you want to make this data open, you need to clarify and describe the characteristic of this data. When and where was it collected? How was it collected? What was the purpose? So everything about your data is metadata. And when you want to upload something to open repository, you have to mention and answer these questions. What was your institution? What were the people, for example, or citizens that were involved into your research? Maybe some tools, software, doesn't matter. So these are the tools and description how you collected this data to make it visible and trustworthy. Yeah. So coming back to findable. So all this data can be findable if you mention metadata in a proper way. You describe everything, you do not hide anything, and everything is clear. For example, all data and even researchers, they have a persistent identifier. For example, DOI. When you publish your paper, every paper has a DOI. So DOI, it is something that helps you to find information faster. That is why it can be easily findable. Without this persistent identifier, it wouldn't be impossible. It would be really impossible. So, for example, principle one is the most important, because if you don't know where to find it, what we're speaking about, how can we speak about something open if we cannot find it at all in our world? Yeah. And here are some more examples of this persistent identifier. For example, ORCIDs, or for example, you can see some identifiers of chemical substances. No, some people who deal with chemistry, they know what I mean. Or different kind of classifications and, indexes by which you can find some kind of a metal or substance which you need to discover or to use, or just a number of archives and so on. Yeah. Even URL. Yeah, this is persistent identifier of some kind of a source. Okay, the next principle is accessibility. Access, we've discussed with you that if you found data, you should be sure that this data is accessible, not just a title or just some kind of person uploaded this data, so and we are happy. No, it means that I can look at this data, I can use it, so it should be accessible. And again, it's about metadata and different types of documentation which allow you to do it. For example, if we click here, how we can do it? We can do it, it's using different types of, for example, protocols. Or you can see that most data producers will use special identifiers for this data. For example, HTTP, when we copy link, the first letters for IT specialists, it's understandable. Or this acronym as FTP, it's also some kind of index or identifier of something. Yeah. So if you have this identifiers, you easily understand what is this data and how to access this data. And sometimes it's not. Sometimes it's important not just to click and open this data. We should be aware that some data might be dangerous, or we can might be like a phishing protocols or some kind of even viruses. So if you see, for example, on the link something.com, you understand what it means, or something.gov, yeah, G-O-V, you understand that this is something provided by government, so it is a verified and credible source. Yeah, so it's about accessibility, how it is marked. Next, interoperable. It is needed to integrate with other data. You remember that we need open data because it is flexible and we can use it, reuse it, adapt it, adjust it according to our needs. Yeah, so if this data is in some very strict license, or maybe some very strict file storage, it will be difficult to reshape it or reuse it. Sometimes it's necessary to address to author, for example, to inquire about the access. It's also possible, and sometimes it also helps to collaborate. And the example here, you can see, for example, the RDF extensive index, and it describes some kind of data set where you can find, and here also some acronyms for data set repositories. And reusable. We've discussed with you that reusable is a key point of open science. So to achieve this, metadata and data should be well described, uploaded, and should be replicable, verified, and you should do it with a high level of responsibility. Okay. And sometimes when you even when you apply for funding, or you apply to some kind of journal to publish a paper, they might send you questionnaire or document where you have to accept, or you have to mention that all your data or your paper follows the FAIR principles of open science. And you have to put tick there. And now you know what FAIR principle means. And if you follow this principle, you have nothing to hide. Okay. So now let's train a little bit. And here, it's something that you can see in your tools or wherever you work on with this Nearpod. What I want you to do here in this with this sign, you can find paper. Just follow this link and you will open this paper. RNA levels in Scotland's wastewater. You don't have to read this paper, and you see this paper is uploaded to Zenodo. This is an open science repository. We will discuss with you later a little bit how to work with it and what it means. But you see that person uploaded here this publication. It is not a pre-publication because you can see this is 2022. This is a post-publication, but you can find it here. What you should do, you should find here proofs that this publication follows FAIR principles. Okay, find here some features, characteristics that prove that it is really open science, because these authors, they follow FAIR principles. When you find it, you just come back to our Nearpod here. It is a collaborative board. And here you can write whatever you want. For example, I want to prove that this is open science because it is on open, it is an open repository. Yeah, so, and I just send it, and here I can see your answer. Yeah, right. So I give you just 3-5 minutes. For those who haven't joined the Nearpod. I will send the link to this paper in our chat. So you can open this paper following the link in our chat and try to find the evidence that this paper, this data set, this is not a paper, really, this is a data set, follows the principles, FAIR principles. Yeah, you remember findable, accessible, interoperable, and reusable. So you can find, access, integrate it into your research, reuse, adapt, whatever. Yeah, great. So F, it is on the internet. The data set is DOI. Okay, speaking about DOI, which principle does it follow? FAIR. Okay, we'll discuss. The metro could be found easily on the internet. Again, which principle is it about? You're right, but it would be next. Yeah, I and R, since all data is available to open, okay? Multiple updated version. Findability, yeah, Lucas, thank you. Right, you are. Persistent identifier. README file, yeah, README file. It's something that I have to mention that, yeah, it really means that it is shared and accessible. Absolutely. Okay, now let's have a look at this paper together and summarize all this idea and find evidence why this data set follows the FAIR principle. So you were absolutely right speaking about the first, findable. Yeah, findable because it has a persistent identifier, DOI. Yeah, whoops, just a second. Yeah, you can just look here, all this. By the way, what you see here, this is a metadata. Yeah, you can see here protocols and data proceedings and whatever you need. And this really, it has DOI, by which you can easily find it. And also it has a keywords by which it's also easy to make a Google search, for example, even. Next, accessible. Really, it can be open from any browser. You don't need to log in. You don't need to sign to this website. Yeah, something like that. So it's just open. If you wish, you upload it, and you can see how many 110 downloads, yeah, and a lot of views. So it really demonstrate this accessibility. And you can see this sign, which means that it is of open access, which allows accessibility. Pretty logical. Next, I is about, I means about interoperability. And you can see here these types of these files. It means that you can open it, you can change, for example, the format of this file, and you can, in general, you can do whatever you want with this data and integrate into your research, or change maybe some kind of, you know, way of it is presented, or if you don't need all this data set, you can just take some part of it. Yeah, so it tells about interoperability. And here also what proves it is special repository where it is. I just wanted to show you. Yeah, it is supplemented to this GitHub. This is a kind of open science resource. We will look at it in details later, but if you see that something is supplemented to this GIT something, because we can have GIT lab, github.com, there are a lot of them. So this is an open resource, open science resource. So it means that this data set is reliable and interoperable, and are reusable. Yeah, absolutely, you were right when you mentioned this README file. That it means that there is a description how to do it, what was done. It's some kind of like a protocol we can compare. And also here you can see just I wanted to demonstrate you this here, yeah, Creative Commons Attribution License, which I CC BY. And you remember that CC BY means the maximum level of openness. Yeah, so it's also example of this reusability. Of course, you can choose stricter license. And it doesn't mean that you don't want to open. No, you open, but you want people to be more respectful, for example, or if, especially if you open some sensitive data, or data maybe which needs more discussions, or maybe you're not sure and you need some peer support or something like that. So you might partially open this data. Okay, so now you know what FAIR principle means and how they work, and we proceed further. The next point is, you remember we discussed with you, it's reproducibility. Why it is important, why some people require that you should follow this reproducibility principle. It comes from reproducibility crisis. Some years ago, researchers and people who are close to science, they identified these issues which are mentioned in this infographic. For example, some people want to omit negative or nil results. For example, when the hypothesis was that something will increase or something will decrease, it depends, yeah, but actually nothing happened because of a lot of things, but nothing happened, and people just don't want to show it. Or when I want something to, I assumed that something would be better, but actually, in fact, it was worse. And I think that this is a fail. I don't want to demonstrate it. No, that is not a fail. It's just an experience. And I also can share this experience with other people to avoid mistakes in future, maybe. And again, it is about trust, about finance, economy, and so on. Or, for example, underpowered study. It means that sometimes statistical power is statistically something was taken for granted. So, for example, if you had a sample of, I don't know, 50 people, and you think, okay, yeah, I took 50 people and this questionnaire demonstrated that something increased. Okay, and then I assume that if the sample is 100 people or 1,000 people, the result will be the same, something increased. But actually, no, it doesn't mean like this. It doesn't work like this. And it means that this number of people, this size of sample also should be counted and measured and proved, and everything should be every point of this example of this experiment should be measured, somehow verified. And in this case, you shouldn't take anything for granted, because this is a science and this is about outcome, about benefits, about real product, money, people health, I don't know, whatever. Or even just or weak experimental design, it's understandable. Or sometimes people, first people collect results and then make hypotheses. So when I see a result, it's not fair, it's not an open, it's not a reliable science when according to results, I just change my hypothesis and make everything coordinate well. It's about fraud. It's a fake science. You shouldn't do like this. You should be honest and sincere, first of all, for yourself. That is why it's also this kind of open science prevent such cases. And it can be prevented using this principle of reducibility. And how to do it? So first, there is an open science practice pre-registration. And you know that if you apply to Web of Science or Scopus indexed journals, before even peer review, they will ask you to pre-register your data on some special repository or some special templates or forms. It doesn't matter. They suggest you list of these repositories, and you can do it even before peer review. So immediately you should make everything you've got open, not only paper, but your data as well. And it is called pre-registration because it is just before peer review and much before even publication. So if you click here, yes, let's go. I want to demonstrate you how to do this. Just short example, how to do this pre-registration. I don't want to make it. I don't have an account in this browser. Okay, we will just skip it. So here is Open Science Framework Home. It's a big, great open science resource. You can find a lot of information about science here, about metadata, about files, analytic and registration. But now we are speaking about pre-registration. And here you can see forms and templates. Usually your editors or people who are responsible for this process, they give you some information and links and list of these repositories where you can pre-registrate. OSF is one of them. And let's look, for example, how people pre-registered this data about what? About qualitative research template. For example, you perform qualitative research and you want to pre-registrate your data. You come to this resource, and here you can find this templates, how to do it, what information you should complete, what data you should use. For example, if you open this file, you can see some more information which you should upload. How to, for example, we discussed with you, yes, qualitative pre-registration template. Just it will upload. While it is just uploading, look at this project metadata. Yeah, I've told you the difference between data and metadata. So metadata is title, description, affiliation, university, maybe some organization, institution, license, date created, modified, for example, and contributors who provide this data. So this is a metadata which should be filled. And for example, this is a template. You remember that this is template for qualitative pre-registration data. And here is like a README file instruction, what to do, what to copy, how to upload, what kind of data you should do, and how to register. And here everything is just for you. So it's not a template that which you can fill. It's something that people have used and they have already completed it. Yeah, so you can see, for example, they've written information about title, description, institution, license, so whatever, and some information which you need to compile with. Yeah, it takes time. It's not that easy, but the Web of Science and Scopus journals, especially those who are from the first quartile, you know, that they have this range of first, second, and the third quartile of this journals. So those which are in the first top rate, they usually require something like that. So don't be afraid if people ask you to pre-register your data. You just know what to do. Okay. So here, I've told you this, demonstrate your OSC registry, where you can just open someone's data as an example, and you can do the same. Okay, now, what are other open science practices which you might face with, and you, for example, should know what they mean? So as I told you, in this Nearpod, everything that is in the blue, it is clickable, and you can click and open necessary resource, which will tell you about some point, some fact, or some information. So I highly recommend you to look through this open research handbook. It will tell you about everything in detail. We just don't have much time because open science is a universe of information, you know, a lot of things. We will just discuss with you key points. So here, if you, for example, don't know about open license or something like that, you can just read and find out. But we are interested in practices. Here is open practices. And you can see that this is a list of these open practices which you should know about. So first, open license, preprints, open peer review, pre-registration, we've discussed with you. Next, publishing peer-reviewed description research as a data paper or preprints, open notebooks, citizen science. Teaching and learning, we have open educational resources. It deals with teachers. We know what it means. Creating tools and technology and facilitate these open research practices. And of course, activities to develop environment for open research in general. So these they're not the list, it's not the final list of these open science practices, because you remember open science taxonomy. There are more than 50 open science practices, but these are key for you as a scientist, as a PhD students. Key practices which we're going to discuss. So first, it is open access. Everyone know what open access means. It means if you want to find data or to find data set or to find a paper, you just use DOI, this identifier, or you can use keywords and you will find this data because it is findable, principle of FAIR. It is possible due to open access. And there are some types of open access. And you should know, because it's really sometimes written that this journal provides green open access. What does it mean? So green journal can't gold open access or even diamond open access. So let's have a look at this green open access. Green open access, it means self archiving. So this is a post publication. It means that, for example, you published something, but it is maybe in without open access, or it is, for example, in your native language, and a lot of people don't understand it, because you know that English is a international language, but you want to open your data, open your publication and demonstrate it to people, and you can make it open in your institutional repository, for example, your university library, your university website. So green open access, it means like post-production. So it is post-publication. You personally find kind of a repository and make your publication open. It's your personal wish, and you can find it. Usually people do it on university resources or websites or libraries. If you want to get this open access and to open your data or your paper for everyone through journal or publishing, it is a gold open access. It means that you publish your paper free of charge, or you pay for the article process fee, doesn't matter. Golden access, it means that you apply to some journal, and they then you perform pre-registration, pre-print, open peer review, and then publishing. This is a gold open access. So people make it open instead of you. And diamond open access, it is about free of charge. Sometimes you can apply to funding, or for example, you can get a waiver and you can be published free of charge. And anyway, your publication will be open. So this is a diamond open access. Yeah. Okay. Tools. Now, let's look at these tools of open access. For example, the first. So why do we need this register and these repositories? It means that all data we discussed with you is accessible and findable. And if you need some exact information which you cannot find just in Google, but I have to say that Google is rather limited source for you. I just don't want to mention AI because they just create, you know, resources. So just if you want to find some specific, reliable resource, please use this open science repository, for example, like this one. You can just use any filter and you find paper, data set, protocol, whatever you need. So you see here are not only data, maybe some kind of, you know, data set, or this is a repository of open access journals. If you want to find exactly journal with open access, you just use this link, and using filters, you can find the journal which you're interested in with open access. And then if you need, you can find out if it is golden open access or diamond open access. Okay. Even there is a repository of open access books. Of course, you can buy something if you want, but you can find some books absolutely in open access. Also, you can use this search option, and please, voila, you have this peer-reviewed open book. Yeah, so it is possible due to open access tools. Next, open data. So not only your open papers should be in open science, but we've discussed pre-registration and open data. So here is the benefits of why we should open data, but we've discussed it a lot today. So we enhance participation, we create new business models, and when we speaking of business, we always want to save money, and that is why should we spend some more money if someone has already performed kind of research, people have some kind of data. I can just use it, reuse it, adapt it, and create new business models. Also, if I am not satisfied with some product, I can improve quality of this product, or even experiment, doesn't matter. Yeah, so open data, as I've started today's our lecture. If I want to see if there is I don't know when my bus comes today, if it is late or not, I just open timetable and I look at it. So this is an open data. Here, how to open up data? What should you do? What are your steps if you are required to open data by editors or by your university, or by a grant giving organizations? Yeah, so they require you to open your data. So it is about publishing data as a supplemental material. It is not about your text, your paper, but it is about your data. And first of all, you can look at these repositories. I've just mentioned you here some of them, but as we opened today Zenoda, this is well known and widespread, and it was sponsored by European Union, and it has, I think it has the biggest data set and base. You can find here everything you want. And here is like, evidence and why you should use exactly this repository. Let's have a look at recent uploads. For example, people here mentioned that everything is open, and what it is. It is a software, for example, or this is a data set, or this is a presentation about something, or again, software to do something. So let's try this software, for example. And you work today with the paper, and when we discovered with you how FAIR principle work. So this is a software with the same descriptive things, with DOI, citation, what else should be a README file, whatever is necessary to do. So you just open this repository, and if you want to upload your data, so first you have to log in, and then you will see the instruction what to do step by step. You should do this, click this, upload this, and so on. It's not that difficult. It's just very friendly user-friendly, I'm sorry. Or this repository, Figshare. Editors, for example, or organization which provide you with money for grants, they allow you freedom. Whatever repository you want, you can just choose which one you want. So it's just up to you. I demonstrate you some of the most known. Again, here you should sign up to users, create your account. And then in your account, you can see these options, what you want to do, upload, download, just find something, manage, share, or publish. And here is also an instruction, a tutoring video, which you can just watch and find out what to do. And for example, if you want to publish big data set, you just click here and you find all information, what to do, how to do it, why you should do it, and so on. So don't be afraid of all these things when people tell you, please pre-register or publish your data. It's okay. It means that this journal or this organization, they follow principles of open science, and it's absolutely normal. Another way how to make your data open, publish a data paper about the data set and in data journals. So we have data repositories and we have data journals. For example, data science journal. Also, you create account. Here is a membership with different plans and different options. It's just up to you, up to your organization, university, doesn't matter. But again, this data science journals allows you to find a lot of data sets, software, hardware, which you need to use for your research or upload your research, and maybe your editors will be satisfied with it. Or even you can publish here something like a paper, but about your data, for example. It's also possible. So you can just look through and find out what you need in details. Okay. Or, for example, here is big data catalog. I just recommend you using it because it keeps a great amount of data about everything. So I just cannot tell you any point which is not in this catalog. It seems, that this is it covers, I don't know, all fields of science, and maybe I just exaggerate because I'm not I don't know, engineer or IT specialist. Maybe it really lacks something. But actually, yeah, it's also a repository, and you can find here metadata or data for your research very easily. And you can also upload here something if it is required. Here is also electronic research notebook. And I've told you that notebooks, it's something like your usual notebook where you write your ideas, insights, and concerns about something. But if you do it electronically, some people can read it, and you can read someone's notes and collaborate, discuss, support, maybe participate in some kind of a project if you think that it's necessary. And if you open here, speaking about data, if you want to make your data open, there are some key principles that you should collect your data in a responsible way. You should prove all your data collection tools. Your data should be stored in a proper way in some open cloud, open science cloud, for example. It also exists, because if you just upload some not verified data, it can cause a lot of mistakes, a lot of problems, and it can cost you your reputation as a scientist. So please be very responsible when you upload your data. And here is a tip: documenting your data, how to do it. What is a README file, how to develop it, how to design it, supporting documentation, which should be about metadata, which you should follow and complete, and some tools for metadata tracking. We discussed, we've today visited this site, fair sharing, and how manage references. And by the way, it's also important, if you use someone's data in your research, you should know how to refer to this data. Yeah, you remember academic integrity, it's critical and very important. Even if you take open data, it doesn't mean that it has no author. So you should refer to author anyway. Okay. Let's move on. The next practice is open materials, or sometimes it is called open hardware. You know, everything which you have material things for your research, for your study. For example, if you deal with chemistry, there are open materials and catalogs of chemical elements, which you can find here if you follow this link. For example, search repository or deposit materials, you can create account and keep your materials, your some kind of formulas maybe here in this kind of repository. Here is a catalog and you can find whatever you want. I mean, just related to specific study, specific science, yeah. Or protocols. This is an official record of your study. It's something like a README file. So it contains clear instructions, what you did, why, what tools you applied, what were conditions for your experiment. And this also well-known protocol IO tool. If you don't know how to create your experiment, what steps should be performed, you can find this protocol here on this site, for example, or also you can upload. And you see here is this running line. So there are a lot of types of these protocols. It can be clinical trials, operational procedures, safety checklist, just manuals, and according to different fields of science, biology, chemistry, whatever you want. And often people collaborate and find each other for great fundings and projects exactly on this platform when they read someone's protocol and they think, yeah, it's interesting. And for example, but I don't have this resource. I'm short of time or I have something to add or contribute to this research. Why not? And due to these open protocols, you can find a partner for your grants or funding or project, whatever. So it's also highly recommended for you to visit. But please remember about licenses. You follow these rules and you can put a license on your data set and your protocol if you want to make it open. This is a great resource of registry of data repository, re3 data, because here is 3 yeah. The same. You can find a data set or protocols here or trials, whatever you are searching for. It's also open repository. You will create your account and you will easily find out how to work with it and what to do. Next, open science practice is open research software and open sources. Software, when you conduct your research, sometimes you need software to calculate some statistics, yeah, or to perform some kind of, I don't know, measurement. And you just search for software, and then when you publish and make your data open, you have to mention which software you've used. Was it credible? Was the software open? Was it reliable? And then other people can use this software as well. And Some journals even have criteria which software they accept as a data collecting or data analyzing tool or not. So please be careful with this open research software. And if you are not sure, or if you're looking for this tool, here are some also links for you. For example, list of specific journals where you can find this information about open software. It's a software sustainability institute. They also contain a lot of information and journals. For example, here you can see this short list, which matches to your need, to your interest, to the topic of your research. You can find it here. Just open and find software which you need. Or research software. The same, this is a journal of open research software. You can publish here. If you, for example, designed a software for research, you are welcome. Or you can find open software if you don't know what to use. And today I've mentioned with you, I mentioned for you these letters GIT, Hub, and GIT Lab. But there are a lot of more, these acronyms. So here are repositories of software and tools for management of this data upload, downloading, and this tracking changes and so on. For example, GIT Hub, also well known and widespread open resources tool. You have to sign up, create your account, and here you can find information about software as well, different types of codes, how to, and it is AI supported. It's like a chat, which might help you to find needed code, create, design. Just take a ready-made software for your research, and you see you can do it here. It performs some functions. You can ask for a code, how to plan, collaborate. You can find here partners. You can find here answered how to automate some kind of a process. And if you're concerning about security, secure your data and so on, it's also welcome here. It is not completely free of charge, but it has a free plan, and it might be sufficient for you at this point. Or GIT Lab, also open laboratory. It also AI supported and powered. And here you can see what you can do with this open resource. You can find tools for planning, source management, integration, security issue, compliances. So it has a lot of different functions, which for you as a scientist, especially engineering scientist, might be very useful. And here is pay attention to this common misconception. Simply putting code online doesn't mean that you made an open software. Actually, software should be accompanied by license, permissions, peer review, the same as a paper, yeah, or data set. So everything should be reliable, and the same goes for software. Okay, ORCID. If you are searching for data or data set or metadata, I've demonstrated you these repositories where you can find it. But if you're looking for a personality of a scientist, of your partner, or you want to look at the scientific interest of this person, or publications, or number of citations, you need this ORCID. And almost all scientists, they have this ORCID. If you still don't have it, please do it. Register in this platform. It is your unique ID, persistent identifier of open science. So this is a platform, how it looks like. So you, again, get an account here, and you will have your ORCID, which you can demonstrate to people, and it is usually required when you publish a paper. And if people are looking for partners, they also can look through your papers, because ORCID, it's a database where everything about your, I mean, scientific and publication is, and education maybe, and also if you are reviewer, it also can be seen from this platform. And if some journals are searching for reviewers, they also can search here on this platform and suggest you to be a reviewer of a paper. Yeah. So ORCID is for persons, and it's really, really important if you want to proceed with your science. So summing up and approaching to the conclusion, how to incorporate open science practices into your research project. So first, you share your data before conducting your research, maybe even before publishing. You do it openly. You choose open repositories. You find open data on open repositories, which means that this data set is reliable and verified. You absolutely benefit from open peer review. You do not accept critique as something that horrible and it might kill you. No, it's absolutely normal process when someone wants to improve your research or your paper. And you can publish non-traditional article types. It means preprints, pre-registration, just data set, or just software. So this is a non-traditional article types. Okay. So here are open science skills. We will just skip this because it's for you. If you wish, you can just look through these skills. But I think that these students who are today with me, you've already got the skills while listening to me. So it means that you know what open science is, you know what FAIR principles are, how to find data, how to protect your data, what are the models of repositories, scientific journals, predatory journals. Be careful, those who do not follow the principles of FAIR, and it is really dangerous for scientists. You know what ORCID means and how to make your personal research profile open. Here is the journey to open science. We started with it from my title page, the first page, and here is. So first you plan. On this stage, you use guideline, open checklist, and then you prepare your management plan, and you can pre-register your study. You can pre-register your protocol, your planning protocol. You can just mention, this is a planning protocol. Then you use electronic notebook to fix or to focus on your maybe some concerns, ideas, insights. You record critical events. You share materials, share your tools, and you also use open repositories. And you remember, everything that you upload is flexible. You just change it. You've discovered some new condition, you found new tool, you want to change it, so please do it. But it is highly valuable when people see that you have been working on your protocol, you're improving, you've added, you've rejected from something. So it is alive, it is open, and people trace your journey. And it means that you're open and you improve it, and everything is absolutely fair in this case. Then analysis, you can find, visualize your data. How? You don't know how to visualize your data. You can use open software, and they will draw a pie chart, for example, instead of you. Yeah. And then publication. This is the most obvious way. Okay. So now, just like a summary for you and just like kind of reflection. So here are personal benefits to adopting open science practices. What I want you to do, you just read through them and choose which of them are the strongest motivators. You just choose two, the most important or attractive for you. Okay, so you just look through these motivators and choose. For those who haven't joined Nearpod, you can just write in chat. Have I persuaded you to apply to open science, to use these principles, and why? Because you want to what? You want to receive higher citations? Yes, it is possible with open science if you have an open access. People will cite you. If you have a closed access, people won't cite you. Very logical, okay? Or, for example, you can get extra people in your team. How to do it? Using open science repositories, protocols, finding partners. Save your own time and money. You can use someone's data and improve it, or it can be like a background for your research. Then distinguish yourself from crowd. Nobody will know that you're so talented or that you've made some kind of a discovery, you know. So due to open science, it is possible. Open science, AI, and please, you have accessibility, you have equal rights, equal balance, whatever. Yeah, so people mention here evidence of your science. Yeah, reputation, agree, absolutely. To form a community, yeah, if you need to find a team, open science is for you. Save your time, get extra value. Yeah. Find evidence of your research, for your research. They say. Okay. So it was just a question for discussion, but we are short of time and so on. So please just consider it when you apply to open science, and if you really want to be open, and if you want to be in a modern current research ecosystem, and you want to find partners and to spread your activity and your achievement, open science is for you. Okay, so now please your questions. If you have no questions, I will comment on the last slide. So here you can find open science tools. If you don't know something, if you don't get something, you can use these resources like a handbook or additional resource for you to, if you need some more explanation or examples how to do something. And pay attention to this last source, 12 things you can do to be open. You just follow this link. It is important for you to perform home task. So you read here 12 things, 12 tips how to become open researcher. Make your research publication, make it fair, release your code, whatever. Yeah, 12 tips. And in Moodle course, in the Moodle course, you will have to perform the task about open science. Here is an example what you should do. You should write how you can make your workflow more open. Here you can see some points. So this is like an example for you. What exactly I, with my research or my paper or my study, it shouldn't be like here, I don't know how many, maybe 12, maybe 15 points here. You just share 7 points how you can make your workflow open. And you will upload this document, this file to Moodle. Okay, So you can use this 12 tips how to become open, or this example. So for example, I will add alternative evaluation. I will communicate through social media with partners. I will publish open access using green, gold, diamond, doesn't matter. I will use open software, for example, like this, or I will design open software. I will share a notebook, and you provide example which open platform or open repository you use with a link. I will open up my data on Zenodo, for example, repository. Yeah, or I will pre-register my data on at Open Science Framework or whatever, wherever you want. Okay. So, have you any questions about your home task? No, I think it's just easy for you. Okay, so last minutes for questions, or if you have any comments, please, you're welcome. No, great. Yeah, Justus, please.
Yeah, thank you very much. You mentioned about the open access, and you also mentioned about the different platforms where we can get materials on open, making science open or open science. One of my questions to you is what I already asked in the chat about how possible it is to available data. If, for example, once someone wants to reuse it, are there particular sites that one would have to look out for, or it's or it depends on what you're looking for? If you can share some insights, yeah.
So you want you want to upload?
Sorry, I asked the question in the chat, but I got my internet disturbed. No,
okay.
To download.
To download, if you want to download.
Open data available for the, yeah.
Yeah, okay. If you are looking for specific data, you can find it at open science repositories. I've put here this, here they are. For example, this one, I've put here a lot of links for you. Here is one of the repository. You just can Google open data repository if you don't have these links. Or also, for example, here, it's about software. So let's come back. Or for example, here, research data repository. Another website, another platform where also you can find and upload necessary data. I cannot do it just right now because you have to create your account first. And then using these filters and search option, you just click here and enter whatever you want to do. For example, let's do it here with this data catalog. Yeah, so for example, I want to find something about what? About water pollution, I don't know. For example, yeah. And please, I can find some kind of data. I've just put water pollution, you know, not very specific and very broad notion, but please, you can do it. You can find whatever you want. And here are the filters as well. You can use. What are you searching for? Tools, data, some vocabulary, some definitions, some terminology, or services, so metadata, whatever you want. The same as Zenodo. I told you about this. You open, again, you just, what we are searching for, water pollution. Wait, water pollution, and please. Articles, book chapter, whatever. I can choose here what I want, publication, data set. So that is why open science repositories exist, open for everyone. You can just find whatever you want. And there are a lot of these repositories. And you will download and upload if you need your data as well. Okay. Any more questions? No. So I've provided you with links also in Moodle course. You can find some necessary links there, or this Nearpod will be with you, and I will also share a link to Nearpod in Moodle course. Okay, that's it for today. Thank you. Have a nice evening and have a nice weekend. See you next week. Bye.
Thank you. Bye.